Hello everyone, welcome to this video, and in this video we're going to be talking about linear inequalities, but with two variables. To start that off, we're going to be graphing the equation x plus 2y is equal to negative 2. The best way to graph standard form is you find the x-intercept and the y-intercept. You find the x-intercept and you find the y-intercept. You find the x-intercept by taking the original equation and you're going to put 0 where y is. So you'll put x plus 2 times 0 equals negative 2. You'll simplify it from there. 2 times 0 is 0. X is now equal to negative 2. To find the y-intercept, you take the original equation and you're going to put 0 where x is. You do 2 times y equals negative 2. We'll divide by 2 and we'll get that y is equal to negative 1. Those are my two intercepts. The first one was at negative 2 comma 0 because we plugged 0 for y. The second one is at 0, negative 1 whenever we plugged 0 for x. So we're going to go ahead and put those two dots on our graph because those two things are going to be on the line. Negative 2, 0, 0, not positive 1, 0, negative 1. Okay, now let's connect those two things with a line. Once you have a line through those two dots, we can continue and see what we have to do with the inequalities. Okay, so this was originally planned to be a partner activity. I'm going to go ahead and say which points you should use. Let's do negative 2, negative 2. We're just going to pick random x's and y's. Negative 1, 3, 3. I'm picking easy ones that you can plug into x and y. 5, 5, 10, 10. We're going to do what it says, which is evaluate x plus 2y. Why would I want to do that? Well, that was the equation. The original equation was x plus 2y equals negative 2. But we're building towards the inequality part. X plus 2y. So I'll do negative 2 plus 2 times negative 2. That would be negative 2 minus 4, which is equal to negative 6. Negative 1 plus 2 times negative 1 equals negative 1 minus 2, which is equal to negative 3. We'll plug in 3, 3. 3 plus 2 times 3 equals 3 plus 6 equals 9. 5 plus 2 times 5 equals 5 plus 10, which is equal to 15. 10 plus 2 times 10 equals 30. Now let's answer this final question, which is, if instead of thinking about it like an equation, what if we think about this question and change the equal sign to an inequality sign? What if we change it to be less than negative 2? What if that's the restriction? Okay, so we just plugged in a random number, and what we're going to see right now is if after we plugged in, will it be less than? Less than negative 2. Let's find out. The first one was negative 6, so yes. The second one was negative 3. That's a yes, but we're getting close to not being. The next one was 9. 9 is not less than negative 2. We have 15. 15 is not less. 10 is not less. 30 is also not less. So what that means is that out of the points that we picked, negative 2, 2, negative 1, 1, 3, 3, 5, 5, 10, 10, only the first 2 points are less than negative 2. Those 2 points were negative 3, 3, negative 3, negative 3, and negative 2, negative 2. Oh, no, it wasn't. It was negative 2, and negative 1, negative 1. These numbers, if you plug them into the equation, are less than 2. I'm going to now give you 5 points for you to plug in and do exactly what I did, but you're going to do them instead of me doing all the math. Okay, so you try 3, 5, just any random points, -6, 2, -8, 2, -1, 5, 0, 0. Do what I did, which is plug them into the equation, and then after that, determine if that answer was less than -2. That's what I need you to do right now. Go ahead and pause the video, and then when you're done, even circling the answers there, then play the video and see if you're right. Okay, I've checked them. 13 is not less than -2. -2 is also not less. It's almost, but it's actually equal to. And the original equation, the original inequality said less than -2, not equal to. The next one is a yes. Next two are no's. Now let's see what it wants us to do after that. It says choose 5 points. Okay, we did that. Plot your points on the graph and highlight those that made the inequality true. Okay, so I guess I'll use orange for the ones that are true, and then I can put a red dot for the ones that are not true. Or I can put a black dot, since that'll blend in. On your own graph paper, do something similar. The ones that got yeses, you can graph them in one color, and the ones that got no's, you can put those points on your graph in a different color. So I need to add -8, 2. There's my final graph with the dots. The orange ones are less than 2. The black dots are the ones that are either equal to or greater than -2. I think I said 2 before, but I meant -2 this whole time. Okay. I hope you drew your graph with a straight line, because once we did that -6, 2, that was really close. It was almost an orange dot, but because it is directly on the line, we have to color it black because it is not a true statement with the inequality. How would you describe the points of the location? You can do that. And then let's solve the inequality for y. That's why we practiced that other thing for the first part of today's lesson. So let's solve this for y by moving x dividing by 2. We get y is less than -1/2 x. I put the x first, and I made the divide by 2 mean 1/2. And -2 divided by 2 is a -1. Y is less than -1/2 x minus 1. Let's see if that matches our graph. Our slope goes down 1 over 2, and our y-intercept is -1, so that is the correct slope-intercept form equation for that standard form equation.